Hello, we're working on section 1.4 in Algebra 3 today, and that is a section that's going to review the real number system that we've been working on up to this chapter. So kind of a great day to get rolling on what we've previously done and solidify that material. So example 1 says using the distributive property to rewrite each of these expressions. Usually when we think of distributive property, example A comes to mind, and I'm going to get my pen right in here, and let's look at A. We're going to take -4 and multiply it through the parentheses, so we're going to distribute it, and I'm going to get -4p, and then negative times that negative will make +20, and there's our answer. For B, it's already given us two terms. What it wants us to do is go backwards and undistribute it. Basically, I kind of think of undistributing as finding that GCF, that common factor. So when I look at -6 and 2, I could pull a common 2 from them. I could also pull a -2. We'll maybe do both ways. So I'm going to pull a 2 out front. And that would say that I would need -3m to make back to -6m when I multiply. And I would need a positive n or +1n to get to 2n. Now, just double check, do a quick sweep in your head, distribute that through, and I would get -6m plus 2n. And that's exactly what we had. Now, I said we also could have decided to take a -2. That would not be incorrect. I mean, many people might have thought of it that way. And I just want to let you know that, yeah, that would be fine. So what if I took a -2 out front? Then I would need a +3m with a -2n. I'm sorry, just a -1n. I've got the 2 out front, don't I? So there I would have -6m plus 2n. Both of those would be correct. On C, I'm looking to see, is there anything in common? And I'm not finding it. So I think this one is done and nothing more is possible to do. D, back to the standard distributive step. Looks like there are 3 terms in that parentheses, so we're going to distribute to all 3. And that's going to give me 20p minus 10q, and oops, that's kind of sloppy, and then plus 5r. Okay. Example 2, using the commutative and associative properties, and bring those back to your memory. I'm sure you've heard of them before. Commutative allows us to change the order of terms. Okay, so it can commute, like you're commuting in a car, you're moving positions. Associative has a kind of in the word, it's going to be things that associate together. So it allows us to change the grouping of the terms. So I can regroup things. Okay. And in this problem, they say to simplify, I want to see what yours looks like, simplify this out. Well, we know we're looking for like terms, aren't we? And I'm seeing some B's together, and I'm also seeing some numbers together. So I'm just going to highlight those things that I want, that I see as kind of like terms. I'm going to include that negative with the 7. Those things I'm going to change the order. I'm going to commute those forward. And you're going to see me write 12b plus 4b minus 7b. And then I'm going to bring in the number parts together, minus 9 plus 1. Notice I had to take that negative with the 7 and this negative with the 9. I know it says subtraction, but we know subtraction is like adding the opposite. So instead, it becomes really a negative number. Now, this was a plus sign there. So I'm going to add up 12b, 4b, and -7. That would give me 16. 16 minus 7 is 9b. -9 plus 1 is a -8. So I have an answer of 9b minus 8. Okay, on to the next problem. Using the properties of real numbers, simplify each expression. Well, that's just kind of what we were just doing. These all have b's in common, don't they? So go ahead and link them together. I'm just going to explain my thought process on this. I tend to put positives together. So in my head, I'm kind of reordering these anyway. In my head, I'm going to add my positives together and my negatives together and then work them finally as the last step. So I get 17b, I say these are equal, 17b minus 16b. And for me, that's just faster. So 17 minus 16 gives me 1b. Obviously, there's nothing wrong with going left to right either. We would come up with 1b as our answer as well. Okay? On the second problem, B, there's the process of distributing, isn't there? I'm going to add a 1 in front of there, and I'm going to think of this as maybe plus -1 so that I can see that it is a -1 that's going to multiply through that parenthesis. That's going to give me 6 minus 2 minus 7. Oh, that's a bad 7. Minus 7 minus 3. Now put like terms together, and that's going to give me -2x. 6 minus 7, or even 6 minus 10, leaves me -4. So however you want to, the order that you want to put those together is fine. But there's our final answer. All right. On C, we've got 4m. The -2 is going to distribute, isn't it? And then the 0.25 will multiply by 12m. So we also have to think of order of operation that we had done earlier in this unit. So order of operation, I'm going to take that -2, distribute it through, and then I'm going to multiply those as well. So I'm going to leave this 4m hanging out front for a moment and deal with it as a next step. So I'm going to get -4n, -2 times -7 gives us positive, not 7, but how about 14m, and then a fourth of 12 is 3m. Now, like terms come together. Here's that commutative property where it allows you to bring like terms kind of all together. That's an m. And then minus 4n. Putting all those m's together would give me 18 plus 3 is 21. So I'm going to have 21m minus 4n. Oops, wrote an m. Bring that back to an n. Okay. Examples of various properties. This is kind of a few more properties that we've learned back in previous years. Identity property. Well, I know addition, if I'm going to add something, wonder what I should add to 9 to get 9. Obviously a 0, right? So 0 plus 9. That's the identity property. I get identical to what I started with when I finish. Inverse property of multiplication. I want to multiply by something, 5 by something, and come up with 1. Well, since it's an inverse, I'm going to multiply by 1/5, which is essentially going to take 5 and divide it by 5 to get 1, isn't it? Multiplying by 1/5 is like multiplying by 5, multiplying by the reciprocal. We had that in an earlier section. All right. Simplify each one. Distributive property. They want us to undistribute on this one as an example of the distributive property. So I'm going to pull that common x out front. Remember, this can be like a GCF process. So I'm going to pull the x out front. That's going to give me 5 plus 8. So obviously we get 13x no matter which method we use. Adding 5x plus 8x or doing 5 plus 8 first, get 13, multiplied by x, get 13x. The associative property means I can regroup. So I'm going to regroup the 5 times the 9. I don't want to change the order because that would be commutative property. So just change your grouping. So we're going to group the first two terms together. Commutative property is changing orders. So that would be like 9y plus 5x. The identity property of multiplication, if I multiply anything by 1, I will get what I started multiplying with. The number that I took was 7 and multiplied by 1, so I'm going to get 7 back. Inverse property of addition. I missed that first negative. If I have a negative 1/4 plus a positive 1/4 TYs, I'm going to get 0. So if I add inverse things, I'll get 0. That is enough. That should cover the problems that you're going to see when you do the evens on this. Look in your textbook under page 36. We're doing 14 through 38 even. And there's those properties down at the bottom. So good luck.